Hello guys, welcome to Bright Grace Integrals, where problems of calculus are easily resolved. So my name is Fego Marius. In today's video, we'll be looking at the questions which says differentiate y equals to x to the power of x. So how are we going to differentiate this? So if you are new to this channel, you can kindly click on the subscription button and hit up the notification bell so that YouTube algorithm will always remind you anytime we release awesome videos like this on calculus. Okay, let's dive in. Okay, actually, at least I forget. This question, we are going to use two methods solving this question. The first method might be familiar to you, but the second method, I believe, might not be familiar. So I will advise you to watch from the beginning of this video to the end of the video so that you can see the second method, which I'm going to use in solving this question. So let's dive in. So seeing this kind of equation, what are we going to do first? We're going to say solution. So we're going to bring down the question which is y equals to x to the power of x. So what am I going to do? I'm going to write method 1 for the first method. Method 1. So actually using method 1, the first step I'm going to do, I'm going to multiply both sides with log. The value, so I'm going to have log y equals to log x to the power of x. So with this, I'm going to apply a principle from logarithm, which says log of x raised to the power of x is also equals to x log x. So at this point, I'm going to apply it to this place. So I'm going to have log y equals x log x. Okay, coming to this point, I'm going to have log y equals x log x. Okay, what is the next step? I'm going to apply the product rule formula in differentiation, solving this with respect to x. So applying the product rule formula, I'm going to have 1 all over y. By the time you are differentiating y, because a question like this is more or less like an implicit differentiation. So I'm going to attach dy dx to this point. So I'm going to have dy over dx is equals to this place. Applying the product rule formula, I'm going to have log x times 1 plus, by the time I differentiate this one also, I'm going to have x times 1 all over x, because by the time I differentiate log x multiply with this one, it's going to give me x times 1 all over x. So I'm going to have 1 all over y dy over dx is equal log x plus, so this s will cancel this s, so we are left with what? 1 value. So what is our next step? We want to make the x to be the subject of formula. In other words, we are using y to multiply this side. Or what are we going to do in a simple form? We are going to multiply both sides with y. So we're going to have y times 1 all over y dy over dx equals y open bracket log x plus 1 close bracket. Okay, that isn't going to cancel out, so we are left with dy over dx equals y open bracket log x plus 1 close bracket. So recall that your y is equals to x to the power of x from the question given. So our dy over dx is equals x to the power of x open bracket log x plus 1 close bracket equals x to the power of x log x plus x to the power of x if we are opening the bracket. So this is your final answer using the first method. Okay, let's see the second method. Okay, coming to the second method, which I said earlier, we'll be applying 2 methods. So this is the second method on how you can solve a question like this, which says y equals to x to the power of x. Okay, let's see the second method. First of all, by the time we set solution for the method 2. Okay, bringing the question down, y equals to x to the power of x. Then we are going to apply a principle from logarithm, which says a equals to b to the power of z is also equals to log b a equals z. So this principle we are going to apply it to this place. So we are going to have log base x y equals x. So with this principle, there's another principle from logarithm again, which says log base x y is equals to log y all over log x. So at this point, we are putting this principle here. So I'm going to have log y all over log x equals x. So what are we going to do next? We are going to use this one to multiply this one. So we are left with log y equals x log x. Remember I said by the time you get to this place, you are going to apply a principle again, which says the product rule principle in this point. Then you are going to differentiate this place in respect to x. Doing that, we are going to have 1 all over y dy over dx is also equals to log x plus x times 1 all over x. Okay, 1 all over y dy over dx is equals log x plus 1. So we are going to use this one to multiply this value here. So we are going to have dy over dx is equals y open bracket log x plus 1 close bracket. So recall that y is equals to x to the power of x from your question. So dy over dx is equals x to the power of x open bracket log x plus 1 close the bracket. Then opening the bracket with x to the power of x, you are left with dy over dx equals x to the power of x log x plus s to the power of x. This is the final answer. And as you can see that this answer also tallies with the first method. I will say thank you very much once again. And also don't forget to hit the subscription button and hopefully hit on the notification bell so that you will also get each of my videos like this on calculus. Fego loves you and the people of Bright Brains Integrals loves you. Thank you very much and God bless you.